Alright, so in this video we go over section 11.3, systems of linear equations by using determinants, aka the Cramer's rule. Alright, but first of all we're going to define what determinants are. Okay, so the notation for a determinant is just like these bars, like the absolute value bars. Notice in this case not the parentheses. No, that's not the notation for determinants, and it is not the brackets as well. So no, it's only just these vertical lines that look like like absolute value bars. And well, you can think of a determinant as a function whose input or domain is a square matrix and the output or the range is only a single number. Okay, just could be an integer, could be could be a fraction depending on the situation. And well, so if we have a determinant whose input is the matrix A, B, C, D, well, essentially what we do in this case is multiply AD and then subtract BC. Subtract the product that goes backwards, add the product forward. Well, that is AD minus BC. So let's do a couple of examples to see how a determinant is evaluated. Well, evaluate each determinant. So in this case, multiply this to, that's -1 times -4, and subtract the product of the two elements in the backwards diagonal. Alright, so that's 2 times 3. And all we do is simply simplify this. So -1 times 4, that's -4, that's +4, minus 2 times 3, which is 6, which equals to -2. Final answer. Okay, let's do the same over here as well. 2 times -5 minus 0 times 7. Well, that quantity is going to be a 0. Okay, so that's -10 minus 0, which equals to -10. All right. What about the determinant of a 3 by 3 matrix? Well, so if you look at the book, you will find this formula that evaluating a determinant of a 3 by 3 implies to evaluate 3 determinants that are 2 by 2. The other method is the method by doing diagonals, which is very similar to the one we did when multiplying vectors, for the cross product of vectors. Which and I rather do that method. If you want to go back and use this formula, just substitute the values, b1, b2, all these values, and you should get the same answer. I'm gonna do the other way by diagonal. So all we do is repeat the first 2 columns, and then from here all we do is multiply diagonal 0 times 3 times 4, that's going to be 0, that's the first product. And then 5 times -1 times -2, that's negative times a negative, that's a positive, that's a plus 10. And then 1 times 1 times 2, that's 2, plus 2. And then we are going to subtract the products, the elements that go in the backwards direction. 5 times 1 times 4, that's positive 20. And then 0 times -2 times 2 times -1 times 2, that's 0. And last but not least, 1 times 3 times -2, that's -6. Alright, and all we do is simply simplify these quantities. 0 plus 10 is 10 plus 2, that's 12, minus 20 plus 0 minus 6, that's going to give us -4, that's a 14. And 12 minus 14, this equals to -2. Alright, how do we use this determinant method to solve systems of equations using the Cramer's rule? Well, the Cramer's rule involves evaluating a couple of, for at least for the 2 by 2, we need to evaluate 3 2 by 2 determinants. So we're given this generic system of equations, two equations, two unknowns whose coefficients of x are a and c, and the coefficients of y are b and d, and the constant terms that are on the right hand side of the system of equations are h and k. So we need to evaluate d anyway. So d will be the determinant of a, c, b, d, which you know how to evaluate that. And then to find the x value, we divide the determinant d sub x. Well, how do we obtain the d sub x? For the d sub x, we're going to use basically the same d determinant, but I'm going to replace the elements in the first column with those of h and k. And then we divide by d. And then for y, to find y, we will need to find the dy, which in this case dy is obtained by using the same d, keeping the same a and c, but we replace the y column, which is b and d, we replace it with the elements h and k, and then divide by d. Well, let's actually solve a system of equations just to show you how this works. All right, so number one, let's use the Cramer's rule to solve the system of equations below. So we need to find the determinant of the coefficient matrix. The coefficient matrix is going to be formed by 3, 4, 1, negative 2. Okay, let's evaluate. That's D. Let's evaluate that. That's 3 times negative 2 minus 4 times 1, which equals to 3 times negative 2, that's a negative 6, minus 4, which equals negative 10. Okay, so now I need to evaluate dx. So for dx, I'm going to replace the column of the x's with the constant terms. In fact, I'm going to use a different color just so you can see. I'm replacing negative 7 with negative 9. I guess it's more visual once we do an example rather than just going the symbols here above. For negative 2. And let's evaluate this determinant. Well, so negative 7 times negative 2 minus 4 times negative 9. And in this case, 7 times 2, which equals 14. Negative times a negative is positive. Minus a negative number, which is plus 4 times 9 is 36, which equals to 50. Let's do the same to find dy. In this case, I'm going to keep the x column, 3, 1. But in this case, I'm going to replace the y column with those elements that are in the constant, that are the constant terms. All right. So let's evaluate this. 3 times negative 9, that's negative 27. Well, 3 times negative 9 minus negative 7 times 1. So in this case, that's a negative 27 plus negative turns into a plus 7, which equals to negative 20. All right. So we have all the information that we need. Now we are ready to find x. Instead of evaluating this huge quotient of determinants, we can just use d sub x over d and d sub y over d. So x equals d sub x over d, which in this case d sub x is 50 and d is negative 10. That's going to give us negative 5. And as for y, we divide. We find the quotient between d sub y and d. Okay, in this case, d sub y is a number negative 20 over d, which equals to negative 10. And in this case, this gives us positive 2. That's the final answer. So the solution set will be the order pair negative 5, comma 2. And that's one example of how to do a 2 by 2 system using the Cramer's rule. Again, as in a nutshell, find d from the coefficients of x and y. Find d sub x by replacing the first column or the column of the x's with the column of the constant terms. Find d sub y by replacing the column of the y's or the column of the coefficients of y with these numbers that are the constant terms or the right hand sides of the system of equations. Let's do one example to use the Cramer's rule for a system for a 3 by 3 system. And yes, this one is going to take a while. Yes, I'm going to do the whole thing. And in this case, well, this is in the generic system. Well, if you read the book, they might use these different symbols, but essentially it's the same. So first we need to find d, just the same way we did it in the 2 by 2. So d is found by evaluating the determinant of the coefficient matrix. D sub x for the coefficient matrix, replace the x column or the column of the coefficients of x with the constant terms. To find d sub y, we replace now the column of the y coefficients, that is the second column, with the constant coefficients. And finally, d sub z, we keep the first two columns of d, of the original d, but we change the third column, or we replace them with the constant coefficients. Yes, this one is going to take a good minute to solve. But let's see. So what we have, use the Cramer's rule to solve the system. All right, so let's see. So number one, we need to evaluate d, the determinant d. All right. So what we do, write down the coefficients 1, 3, negative 2, negative 1, 2, 3, 1, negative 1, negative 1. So what do we do? In this case, well, I'm going to use the shortcut by repeating the first two columns, 1, 3, negative 2, negative 1, 2, and 3. Okay, so what are we going to do? So let me multiply in this direction. 1 times 2 times negative 1, that's going to be negative 2. And then negative 1 times negative 1 times negative 2, that's going to give us negative 2. And then the third, that's going to be 1 times 3, which is positive 9. And then I'm going to subtract the products in the other direction. Negative 1 times 3 times negative 1, that's going to give us a positive 3. And then 1 times negative 1 times 3, that's going to give us negative 3. And last but not least, 1 times 2 times negative 2, that's going to give us negative 4. Alright, so good news, these two go away, cancel out. And then what are we going to get? Negative 2 minus 2, that's a negative 4. Negative 4 plus 9, that's positive 5. And then minus the quantity negative minus negative 4, which is actually plus 4, that equals to 9. Alright, so that's the first result. The second result will come from d sub x. For d sub x, I'm going to replace the coefficients of x with those that are the constant terms. That is negative 4, 5, 15. And then the other columns remain the same. Negative 1, 2, 3, 1, negative 1, negative 1. So we're going to use the trick again by repeating the first two columns to do this quicker. So what do we do in this case? Well, let's multiply in this case, well, negative 4 times 2 times negative 1, that's negative 4 times 2 times negative 1, that's a positive 8. And then negative 1 times 15, that's going to give us positive 15. And then 1 times 5 times 3, that's 15. Okay, let's do the backwards multiplication. So we are going to subtract what we obtained from the backwards multiplication. Negative 1 times 5 times negative 1, that's positive 5. Negative 4 times 1 times 3, that's going to give us 12, positive 12. And 1 times 2 times 15, that's going to give us 30. That's going to give us, well, for the first sum, 15 plus 15, that's 30 plus 8, that's 38. And then minus 30 plus 12 plus 5, that's 47. And 38 minus 47, that's negative 9. Let's do the same to find dy, d sub y. So that's going to give us, well, in this case, we're going to keep the first two columns of d. That is, the first and the third, 1, 3, negative 2. I'm going to keep the third one. 1, negative 1, negative 1. But we are going to replace the middle column with the constant coefficients, negative 4, 5, and 15. And we're going to do the same. Let's do the repeating the columns. Okay, let's multiply forward. 1 times 5 times a negative 1, that's negative 5. Negative 4 times negative 1 times negative 2, oh, there's a lot of negative, that's a negative 8. 1 times 3 times 15, that's 45. And we are going to subtract the products that go backwards. Negative 4 times 3 times negative 1, that's 12, positive 12. 1 times negative 1 times positive 15, that's negative 15. Last but not least, 1 times, oh, I should have used pink instead. Yep. 1 times 5 times negative 2, that's negative 10. All right. So let's simplify this. Negative 5 minus 8, that's negative 13. Negative 13 plus 45, that's positive 32. And then minus, in this case, be careful because we're going to have 12 minus 15 minus 10, which is going to give us negative 13. This quantity is going to give us negative 13, but minus negative 13 turns into plus positive 13, which equals to 45. Let's do the fourth one. The z equals to, well, keep the first two columns that are 1, 3, negative 2, negative 1, 2, 3. But in this case, because we're looking for c, it is our third column that gets replaced with the constant coefficients, negative 4, 5, and 15. So 1, 3, negative 2, negative 1, 2, and 3. So let's multiply. 1 times 2 times 15, that's 30. Negative 1 times 5, negative 2, that's positive 10. And then negative 4 times 3 times 3, that's negative 36. Minus the products in the backwards direction, negative 1 times 3 times 15, that's negative 45. 1 times 5 times 3, that's positive 15. Last but not least, negative 4 times 2 times negative 2, that's going to give us 4 times 4, which is positive 16. So this will be equals to 30 plus 10, which is 40, minus 36, that's going to give us 4. Minus, in this case, careful, because 16 plus 15 minus 45, that's going to give us negative 14. Minus negative 14, that's going to be a plus 14, which equals positive 18. And now that we have the 4 magic numbers, that is d sub x, d sub y, d sub c, I'm going to go back to use these formulas here to find x, y, and c. Alright, so x, which is d sub x over d. Y, which is d sub y over d. And z, which is d sub d. D sub z over d. Alright, so let's use our numbers. So d sub x, which in this case is negative 9, divided by d, which is 9. That's going to give us negative 1. D sub y, which is negative 9 over here, 45, over d, which is 9, that's 5. And last but not least, d sub z, which is 18, over d, which is 9, which is equals to 2. Alright, so our solution set that's going to be negative as an order triple, and that's negative 1, 5, and 2. So just a quick comment on when solving systems of equations using this method. The minute you get that d is equal to 0, this system may not have a solution, or may have infinitely many solutions. Well, I would like to quickly comment on that. So d equals to 0, what happens? So if d sub x and d sub y and d sub z, they're also equal to 0, then we have infinitely many solutions. But otherwise, if d sub x is not 0, or d sub y is not 0, or d sub z is not 0, then no solution. So it always helps that's why we always evaluate d first. Well, if we get any constant that is not 0, then we keep going and evaluate dx, dy, and dz. But the minute we get 0, then we have these two scenarios: infinitely many solutions or no solution. And this is the end of this video. I will see you in the next one.